The picture shows my decision die in 3 different positions. What is the probability to roll yes with this die? Possible to take away first die on the picture. So these 3 are different positions of the same die. Eh? Die is singular for dice. So if we look at we rotate the first cube to the second position. Rotate. Then the YES they go to the top. And the YES become spell upward. Okay. Then we look at the yes on the left face of the third die, third position. It cannot be either of the yes on the first cube. If it is inverted, it cannot be the either of the yes in the first cube. This shows there are 3 faces with yes, 2 faces with no, and 1 face with maybe. So probability to roll yes is 3/6 equal to half. Okay. Second question. Question 12. The length of a side of one square is 1. What is the minimum distance you walk from start to finish if you can only move along the sides or diagonal of individual square? So 1 square, 1 unit, the side is 1 unit. You can also move along the diagonal. So what is the argument or reasoning is important here, We say that if you want to move diagonal, then there can only be 2 diagonals you can move. The more diagonals used, the shorter the walking distance. The walk can move at most along 2 diagonals towards the finish. So you want to walk more diagonal, cannot, no more already, at the most is 2 only. So 2, so the diagonal is 2√2. Then you have to walk along the sides. So 2 plus 2√2, answer. 2 plus 2√2. So important argument is the maximum is only 2 diagonal. And you must use the maximum to get the shortest. Number 3. Every inhabitant of the Winger planet has at least 2 ears. 3 inhabitants named Emi, Dimi, Trimi met in a crater. Emi say, I can see 8 years. Dimi, I can see 7 years. Trimi, that's strange. I can see only 5 years. None of them could see his own ears. How many ears does Trimi have? So we form equation. First, Emi can see 8 years. Emi can see 8 years. So you see the Dimi and Trimi together must have 8 years. Dimi see 7 years is because of Emi and Trimi, 7 years. Trimi say 5 years. So Emi and Dimi, I plus D. So you have enough equation to solve already. How many, what is the value of T? How many years does Trimi have? So this equation you want to see how to solve in a shorter number of steps. So usually this type of cycle, D plus T, I plus T, then I plus D. Cycle. So we add all together first. Add all three equations. So we get 2I, 2D, and 2T, which is 8 plus 7 plus 5, 20. So I plus D is 10. And then you use the fact I plus D is 5. 5 plus D is 10, and T is equal to 5. So this is, I think, the shortest number of steps. If you substitute one at a time, it will also get the answer. But one trick is to add all the equation, which is quite often in many cases. Number 4. A recipient was of the form of a rectangular prism whose base is a square of side 10 cm. Is filled with water up to a height h. A solid cube of 2 cm of h is put in it. The minimum value of h such that the cube keep fully submerged in the water. So at first, you have water inside a rectangular prism. Then you put the cube inside. You want the height h to be minimum. So you want the water to rise not above the cube, up to same level as the cube. Okay. So when the cube is put inside, then the water rise. The water rise because the cube displaces the water. So the volume of water that rise up equal to volume of the cube. The water level rose from h to 2 cm, level to the cube. At first, it's less than 2 cm. So it become level to the cube. So, but the base is 10 by 10. So the volume all together, the cube plus the water is 10 by 10 by 2. But volume of cube equal to volume of water displaced. And the cube take the place of the water, so the water rise up. So the water 10 by 10 times 2 times h. And the cube is 2 times 2 times 2. So 2 minus h equal to 0.08. And divide by 10, divided by 100, 8 over 100. So 1.92. Okay, next question. The square ABCD has area 80. Points E, F, G, H are on the sides of the square, and AE equals BF, AE equals BF equals CG equals DH. If AE is 3 times, what is 3 times EB? What is the area, shadowed area? So I draw a bigger diagram to label the label. So 3 to 1, 3 to 1, here 1 to 3, and then here is 1. Then we plan to find the area, so we draw this line, dotted line. So we have 1 and 2, because we label 1 and 2. Now, calculate, call this is the center of the square, because of the symmetry, you must pass through the center of the square. Then we can find EG. 2 square plus 4 square, Pythagoras theorem. 2 square plus 4 square equal to 20. So EG is 2 root 5. I forgot to type EG. Square root lah. Then we know HF and EG perpendicular. Don't need to prove lah. Just use gradient. The ratio here 1/4. 2/4, not 1/4, 2/4. The other one is 4/2. The height here 4/2. Then 2/4. When this happens, the lines are perpendicular. In coordinate geometry, we say product of gradient is -1. One of them is -half, the other one is 2. Half times -half times 2 is -1. Just say perpendicular. We want to answer the objective. Choose the answer. So M center, and therefore is the midpoint of HF and HG. Midpoint. So ME equal to MF, ME, MF, MG, MH all equal to square root 5. Because EG is 2 root 5. You calculate the 2 root 5, so half the length, root 5. So half base times height, root 5 times root 5 is 5. 5/2. MH root 5. I didn't label, that's why. Root 5. Root 5 times root 5. Then double twice. So answer shadow area is they ask what is the shadow area? Triangle, half base and side is 5. 2. Answer 5. I don't have. Oh, the area is 80. Area is 80. Area is 80. So we here must times the scale. Scale up. Or I forget to use the fact that area is 80. So if we use x, 3x and x, then 16x squared is 4x squared times 4x squared, 16x squared. Equal to 80. So you can say x squared, how much was that? X squared is 5. Now, here is 2x and 2x. Here is 4x. Just now I use 1 unit. So 20x squared. 20x squared. 20x squared is EG. EG is 20x squared. Let me just put it here first. So 2 root 5, 2 root 5 times x. EG. So so the is x root 5. X root 5. X root 5 times x root 5, pi x squared. Is must times half, pi over 2, half root 5 times half base times height. So shadow area 5x squared. 5x squared. Five x squared is 25. Answer, huh? 5 squared is 25. X squared go to 5. It's I didn't use the 80. Okay, we go to the next question. The product today, the product of the ages in integers of father and son is 2015. What is the difference of their ages? So we only have the number 2015 to do the reasoning. Father times son, 2015. Cannot be son 5 years old, father 403, cannot. Then we know 403 is divisible by 13. So we find that 5 times 31, also 105. Too old. So we must 5 times 13, 65. So son is 31, father is 65. So the difference in the ages, 65 minus 31 is 34. Answer is D. Next question. This question we skip, not very clear the diagram, the level, heavier or lower. Skip. Okay. If the two roots of the equation x squared minus 85x plus c equals 0 are prime numbers, the roots are prime number, what's the value of the sum of the digit of c? This one from 4 topic, so we'll learn a little bit of the theory. The x got two values, because quadratic. Then you can form the quadratic equation. X minus alpha, x minus beta is 0. So that x equal to alpha and beta. But if we expand, then we got x squared, then we got alpha x. We also got beta x, both negative. So alpha x plus beta x equals 0 lah. So you can see the equation. Alpha plus beta is 85. And alpha plus beta is the coefficient. They are the roots. Let the roots be alpha beta, then alpha plus beta is 85. This both negative and negative, so alpha beta is equal to positive 85. But they are prime, and the question says that the roots are prime. Alpha is prime, beta is prime. But prime plus prime, normally odd number plus odd number. Then it cannot be odd one. So we must have one prime that is even, and that is 2. Odd prime plus even prime only can get odd number. So we must have 2 and 83. So C is equal to alpha, beta, and C. C is 2 times 83, 166. Sum of the digit of C. So 1 plus 6 plus 6, 13. Okay. Question 19. How many 3-digit positive integer are there in which any 2 adjacent digits differ by 3? A 3-digit adjacent. So means first and second adjacent. Then second and third adjacent. So only 2 pairs of adjacent digits. So how to start like that? Since the middle number is adjacent to the 2 other numbers, we use what happened? Okay, something wrong with my click here. So I use a center number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the front and the first and the third must differ by 3. So only number is 303, then 414, then 525. But when you reach 3, we can have 636 or 630. We cannot have 036, cannot start with 0 lah. But when you have 4, then you have 747 or 147 or 741 or 141. So we keep listing the number 858, 852, 258, 252, 969, 963, 369, 363. Then it comes to 7, then leave 474. Cannot have other number. You cannot add already. 7 plus 3, 10 already. Similarly, 8 minus 3 only. 8 minus 3 is 5, 9 minus 3 is 6. So total 20 numbers. 1, 2, 3, here 5, here 12, here 3. 20 there. 1, 2, 3, 12, 13, 14, 15, 16, 17, 17 plus 3, 20. Answer 20. You can also use a different approach. We can say first digit all 1, 2, 3, 4, 5 until 9 only. I cannot have 0. Then you try to make the number increasing, become bigger and bigger. So 1, 4, 1, 1, 4, 7. When you start with 2, you have to use 5. Then you want the smallest, so 2, 5, 2. After that, 2, 5, 8. So 303. Then 0, you have to change to 6. Then 363, 369. So this also systematic, increasing. Also 20. Next question. In this question, you want to use the word counter example. Which of the following is a counter example to the statement? If n is prime, then exactly one of the numbers n minus 2 and n plus 2 is prime. So if n is 11, then n minus 2 is 9. 11 minus 2 is 9. 11 plus 2 is 13. So exactly 1 is prime, exactly like that. So we notice that for 19, we have 17 and 21. So exactly 1 is prime. For 21, we got 19 and 23. Nineteen and 23. So both prime, they're not. So it's a counter example. N is the 21 is not exactly, not exactly 1 is prime. 2 prime. Then if N is 37, then we got 35 and 39. Then we got 2 composite. So both answer, no? Which of the following? C also correct, E also correct. The counter example must not have exactly 1 prime. So this one don't have exactly 1 prime. This one also don't have exactly 1 prime. So both are answer. The figure shows 7 regions enclosed by 3 circles. A number is written in each region, and it is known that the number in any region is equal to the sum of the numbers in all neighboring regions. We call two regions neighboring if they share their boundaries, if their boundaries have more than one common point. Okay. Two numbers are shown in the figure. Which number is written in the central region? Let's draw a bigger one. So these two, 1 and B, are neighboring because they got this boundary. The question says boundary have more than 1 point. So many points on the boundary. So A and 1 neighboring. E and 2 neighboring because the boundary have a lot of points. So we got to find the value of E, the number in the central region. So form equation, it is sum of the neighboring name in the neighboring region. So A is neighbor to 1 and 2. There 1 point only cannot. E cannot. It must have more than 1 point. So 1 plus 2, A. Then B is 1 plus C. B 1 plus C. And then D is 2 plus C. Our aim is to find E. So let's write E also. E is B, E. E is B plus D plus 2. No, no, C, C. C is B plus D plus E. C is B plus D plus E. I write C. Then I substitute B is 1 plus C. And then D is 2 plus C. And then E is 1 plus 2 plus C. So like that, no more, only C left. So always think in this way. Use which one as your anchor. I see C here, C here. Then the E also, E, if I include C here, it's better to include C. Include what? E. E is 1 plus 2 plus C. So we see so many C. That's the reason. We see so many C, so we change all to C. So C is -3. Yeah. Okay, 3C here is 6. -2cc. So C -3, E 0, answer 0. Huh? Petra has 3 different dictionary, 2 different novel. How many ways are there to arrange the books if she wants to keep the dictionary together and the novels together? So dictionary all different. We call it D1, D2, D3. Yeah. A novel N1, N2. Like that. So arrange must be together. So D1, D2, D3. You arrange is factorial 3. N1, N2, 2 ways only. N2, N1 or N1, N2. And then we can swap N2, N swap to the left. D, 3D all swap to the right. So this D 3 factorial, the N is 2 factorial, and the swipe 2 ways, D on the left or N on the left. Answer 24. This one is permutation combination. Typical school textbook problem. How many 2-digit numbers can be written as the sum of exactly 6 different powers of 2, including 2 power 0? So we want powers of 2. We write down the powers of 2 first. So 2 power 0 until 2 power 6. 2 power 7 is not required because we want 2-digit numbers only, written as the sum. So we study this, then we must have used 6 of them. Exactly 6. So if I use 64, I cannot use 32 already. So then I use the other 5. You cannot use already, no choice, must use the other 5. Similarly, if I use 32, then I cannot use 64 already because I need 5 more. So I must use the first 5 again. So 32 one time, 32 one time, 64 one time. So only the two numbers that can be written as the sum. So you see the reasoning, either use this or this. So 2 ways only. Next question. So we have a triangle ABC. We draw a parallel line parallel to the base through X and Y. The area of the shaded region are the same. So the trapezium here, area equal to the triangle here. The ratio BX to XA is 4:1. What is the ratio of BY to YA? So this one we use ratio of area. Don't use half base times height. Use ratio of sides is square the ratio of sides, square the ratio of area already. So 4:1, you can write the ratio. If the ratio is 4:1, then the 16 over 25. The whole area is 25, then inside is 16. So 16 plus 9. Here is 16 out of 25, out of the whole area. So here 16 parts, here is 9 parts. Not area 16, the ratio. 16 over 25, so 16 and 9. Then this part, shaded area 9, then this part must be 9. So 9 over 25. If the area 9 over 25 must be 3 to 5. Huh? Side ratio must be 3 to 5. So 3 here, 2 here, so that 3 to 5. Therefore, answer BY to YA is 3 to 2. So no need to use half base times height. Huh? In a right angle triangle, the angle bisector of an acute angle bisects the opposite side into two segments 1 to 2. So this is the bisector. Then right angle 90 degrees. This 1 is to 2. What is the length of the bisector? If you know angle bisector theorem, then you know here is also 1 to 2. But if you don't know, then you can draw a line parallel to the bisector, and then draw the intersection. So you have parallel. So parallel means if here 1 to 2, then if here is x, here will be 2x. The angle theta I was trying to show bisector here is theta. So if parallel, then this angle equal to this angle. Then this angle equal to this angle, alternate angle. Then because here 1, here is 2, then here is x, here is 2x, parallel. Then because the angle theta equal, here will be x. So here x, here is 2x, and then here is 3. So x squared plus 3 squared equal to 2x squared, Pythagoras theorem. 3x squared equal to 9, x squared equal to 3. You want the length of the bisector, which is 1 plus x squared, then square root. L squared is 1 plus x squared. This is L, capital L. The 1 plus 3, 4. So L is square root 4. Square root 4 is 2, right? Actually. So angle bisector theorem, if here 1 to 2, you can use the result here 1 to 2. If not, they will prove by this construction. Draw a line parallel to the bisector. Then you can see the similar triangle here 1, 2. So x to x. That's quite a clever construction found in many books. 26. A two-digit number with digits A, B, C can be written AB. Let A, B, C be different digit. How many ways can you choose the digits A, B, C such that AB less than BC less than CA? So we have the inequality to start off. AB less than BC less than CA. Then they are different. No equal. So we can safely say A is less than B and less than C. Now, what's the next thing you can do? we let A equal to 1. A 1. So we have to have 12, 13 until 18. 19 cannot, because then you must have 2x. Then x must be 9. If we put 9, then here cannot. There. So we have stop at 8. So BC we have 23, 24 until 89. Then this C and C, the same one. Then here is A. A is 1. A is 1. So the last digit all 1, because A is 1. So X can be 3, 4, 5, 6, 7, 8, 9, 7 numbers. For the second row, 4 to 9. For the last row, only 9. So 7, 6, 5, 4, 3, 2, 1, like that. Okay, we know the pattern already. When A go to 1. So when A go to 2, you can know that it starts with 6 numbers. 2, X can only be 4 up to 9. Those 6 numbers, 6, 5, 4, 3, 2, 1. Then if we look at start, A go to 6, then 7, 8, 8, 6. Then 6, 8, 8, 9, 9, 6, 2 only. And the last one is 7. Cannot. A maximum 7, then 8, then 89, and then 97. So 1 only. So getting less and less. 2 rows, 1 row here, 7 rows, 6 rows. If we show all the rows, the first case A go to 1, got 7 terms. And then after that, A go to 2, 6, 5, 4, 3, 2, 1. And then 5, always 1 less, 1 less, 1 less, 1 less. So we add up all these, will be all the numbers, which is 84. Answer is A. This making a list, but because of the pattern, your list is what partial. Some are shown first and last, usually must show. So making a list to help you do the counting. Counting include ordering the list. Next question. When one of the number 1, 2, 3 until n was eliminated, the mean of the remaining numbers was 4.75. Which number was eliminated? If you try for a few numbers, like 1 to 5, that's one way to see how to go for more numbers. But let's do 1 to n. Then we find the sum, because we got the mean, so we need the total. So one number is eliminated. We don't know which one. We put it x. X is eliminated. So we subtract the new total, divide by the one number less. The mean is 4.75. Okay. So average times, because x eliminated already, n minus 1 number left. Is the new total with x eliminated. So this is our equation. We want to find x, but got 2 unknown. So we have to look for some properties in the equation. So you can do intelligent guess. Multiply by 4. Because here 4.75, I want to get integer. You multiply by 2 is 9.5. So multiply by 2, 9.5 times 2, 19 is better. So half times 4 is 2. So x become 4x. Then we got 2n squared plus 2n minus 4x, 19n minus 19. And arrange so that x is separated and get the quadratic on the left side. I put 0 here. Oh, in the end, I realized nothing can be done. So I make the 4x, it's a constant because x is a number. It's fixed number. So we have a quadratic equation. At Form 3, I think some school will teach the formula. If you have a quadratic equation, you want to find n, there's a formula. I don't want to prove lah. Later, next time, we can sure prove also. This is the formula to find n. Our A is 2. The B is negative 17. And then this C is in terms of x. But n is an integer. N is one of the numbers, integer. So you must square root perfect square. Must have perfect square. So I say b square minus 4ac. B is 17 square, negative 17 square is 289. 4ac, 4ac. A is the first coefficient. A is 2. C is 19 minus 4x. So this one, the square root, we must first get integer before we can get n integer. Of course, you still have to make sure the whole thing is integer, but before that, we necessarily must have square root perfect square. So must have y square. This one must equal y square. That is the approach I use. Maybe got other way. Then study. Study 4 times 2, 8. 8 times 19 minus 4x. 17 square minus y. This 289 is 17 square. Then I realized 4x has to be quite big. 4 times 5 is 20 already. So I rearrange 4x in front. 19 is at the back. So y square in front. And 17 square at the back. Now, what is the next idea? What is the next idea required here? We notice that y must be bigger than 17. So we try y 18 like that. And then or 19. If we subtract, we must get multiple of 8. Number must be divisible by 8. So I tried 324 minus 289. 35 cannot. Then I tried 361, 289, 72. Then it's a multiple of 8. So we can work out and see what happened. 8 times 4x minus 19 is 72. Cancel, divide by 8 is 9. 9 plus 19 is 28. X is 7. So when x is 7, we want to find how many numbers n. What is n? We can try to find n. When x is 7, we substitute inside. 19 minus 28 is negative 9. So we get 2n squared minus 17 minus 9 equals 0. So n is integer, so we naturally try to put n minus 9. Then this no choice must be 1 here. Then 2n is 2n squared. And we check, is it plus 1? Type, forget the sign plus 1. So factorize, you get angle 9. Okay, here is negative 18. 2 times 9, 18. Minus 18 plus 1, minus 17. So 7 and 9. So add 1 to 9 is 45. If 7 is eliminated, then you get 38. Then 8 numbers left. 38 divided by 8, 4.75. You can have other answer, Is it? Actually cannot. I got tried to show. Too long the working. But by logic, if you put more numbers, let's say I put 1 to 10. 1 to 10 is 55. I eliminate 10. I eliminate 10, become 45. 45 divided by 9 is 5. The mean is bigger already. More n, mean bigger. So you try to find other answer. Y is 21 or what? No use. The mean gets bigger and bigger. So we know answer must be n and 9. More number mean bigger, because you add bigger number. Every time add bigger number, the mean become bigger one. I think it's good to write down, all this reasoning. Okay. Euler, the n starts on one of the vertices of a cube of side length 1. She wants to walk along every edge and return to her starting point, making the length as short as possible, the journey. What is the length of the journey? So let's see, let's start at 1. If you go to 2, you go 3, 4, 5, 6, 7, 8. Then forced to repeat already, because the blue edges not yet traverse. 4 more not yet traverse. This one. So either we return to 1 and start to go to the every edge, or we can after reach 8 you can go to 5. Repeat. Repeat. Not yet repeat. 5, 8 already we can go to 5. But when come to 5, we have forced to repeat already. So we must have a better strategy, so that it's not confusing. What is reasoning that is required here? We know the number of edges is odd one. Every vertex, 3 edges incident, 3, 3, 3. And then logic is when you go in, you come out. So 1 is remaining one. So you have to go in again one. So every vertex is visited again. Each vertex of the cube has 3 incident edges. Each time the n enters a vertex by an edge, it has to come out by another edge. And there is always 1 edge remaining. The n must enter this vertex again second time, because we want to travel every edge. So 1 remaining, it must later come here and traverse. So every vertex is visited again, and the n come out along an edge not traversed. There you go, 6, 7 already. Later you come back, then you of course choose the one that not traverse. Okay, so that means only this one traverse two times. Okay, this one time only, because we choose to go out here. Okay, you want to traverse this, you have to go in. Go in, repeat. So there's 1 edge traverse twice. And because there are 4 untraversed edges. 4 edges are traversed twice on it. You go in, you have to repeat on. You traverse already. The second time already. There you go. Then I show you the drawing. It's easier. So only 4 edges are traversed twice. The rest once only. You show this kind of technique. It's called graph theory. Easier to see. I start at number 1. 1 go to 2, 2 go to 3, 3 go to 4, 4 go to 5, 5 go to 6, 6 go to 7, 7 go to 8, 8 go to 5, and then repeat, and then come out 3, and then repeat, and then go to 1, and then repeat, and go again, then repeat, and then return to 1. Okay, that's how to show the path. For a journey to return to the starting point, every vertex must have an even number of incident edges. You see, you have odd, you go in, you cannot come out. So I add, so become 4 edges, 4 edges, 4 edges, all 4 edges. So you go in, you can come out. Come out means repeat one of them. Go in, come out, even number. So every vertex has 3 incident edges. We construct 4 additional edges, making every vertex have 4 incident edges. That is good to write down. Then you can show the path. 1 go to 2, you go to 3, 4, 5, 6, 7, 8, and then 5. 5, then you go to 6. 5 go to 6. Just now 5 go to 6 already. Now 5 go to 6. Then 6 go to 3. And 3 go to 4. God also repeat. 3 go to 4, repeat. And 4 go to 1. Then still got edges. So we go to 2. 1 go to 2, got repeat. 1 go to 2, got repeat. Then 2 go to 7. Then 7 go to 8, got repeat. Then 8, of course, go back to 1. We can have more than one answer to go around the edges. Suppose we go 1, 2, 3, 4, 5, 6, 7, 8. You got 8. Instead of go to 5 just now, you go to 1. Then 1 go to 4. Then repeat. You see, 1, 2, 3, 4, 7, 8. Then 1 go to 4. 4 go to 3. So we reverse back. 4 go to 3. 3 go to 6, and 6 go to 5. That means just now 5 to 6, then 6 go to 5. And then 5 to 8, then 8 to 7. There's now 7, 8, 8, 7, 11, 7, 2, then 1. So you can use this kind of technique, label the vertices to trace the path. This type is in internet, got game on. They say, do you know how to go back? If odd vertices can never go back on. If got 2 odd vertices, here got all 8 vertices, odd number. If only 2 odd, then you always start with the odd and go travel. Then you end up with the odd number at the back. Okay, 2 odd number. This is called semi-Eulerian. The one I draw after adding the edges where all are even is called Eulerian graph. Eulerian graph. Do I know all this technique? Because I got teach graph theory in IB syllabus. We still got 19 and 20. We will continue with 19 and 20 next lesson. Question 30 and 20. Okay, you stop here.